Okay, good evening. Okay, today, let me start by finding out those who are present and those who are absent. Let's have order in class first. Move. Let's open this first. So let me mark your attendance register here. Amnyolo, Frida, Morris,
Present.
Sheldon,
Present.
George.
Present.
Okay, since everyone is in. So today we start by looking at polar form of complex numbers. That is 128. And today's topic is about polar form. Today's topic is polar form of complex numbers, and our learning objectives or outcomes of this session will be, by the end of our learning outcomes, be able to define polar form using modulus and argument. And our second objective will be to convert complex numbers from standard form to polar form. Before we continue, let us remind ourselves what we did in our last session, where we were dealing with the equations involving complex numbers. What we did last time is related to what we are about to do today. So we start by doing a recap of what we did last time, and we'll have one example from our previous class of what we did. We had equations. I gave you some examples in class which you are to do, or which we did, and we have to remind ourselves today because it's been a long weekend, and maybe some of us have forgotten what we did last time. So last time we had an example like 2 minus j is equal to root a times jb. And we were in our last class we were asked to calculate this equation or to evaluate this equation. What we did in our class, when they ask you to evaluate such an equation, they are just asking you to find the value of a and b. So in this case, how are we going to calculate it? We can start by, so the solution to this will be, you can square both sides of this equation so that you have 2 plus j minus j3 squared is equal to a plus j b. Is that so?
Yes.
So from this you can expand this b. You'll find 2 times 2, 4. You have 4. 2 times j3 minus j6. We have j times 2 minus j6. J times j3. You have j squared 9, right? Is equal to a plus j b.
That would be plus j squared. Because of minus j plus minus.
Yeah, this will be j squared. Sure, true. So we know the value of j squared is normally given as -1. So from this you can substitute the value of j here. You will find you have 4 minus j6 plus j6. j6 plus j6 you will find 12. j12, right?
Yes.
Then you will find, when you substitute the value of j squared here, you will have -9 is equal to a plus jb. You can add this one and this one, you will find -5 minus j12 is equal to a plus jb. So from here, it is easy to find the value of a and the value of b, because a here represents the real part of the equation, and b here represents the imaginary part of the equation. So you equate the value of a from this equation, you find a will be -5, right? What about b? jb will be equal to -j12. So our b will be -12. This is what we did in our last class. So today I want to introduce something new. We'll start by looking at the modulars. That's what we're supposed to do, to define polar form using modulars and argument. So you can be given a diagram like this one. This is called an Agar diagram. You remember I told you in our last class, this is an Agar diagram. And this is, we have been given the value of from the distance from here, it is a, from here, this imaginary part, it is b, and this is r. So when you are trying to find the value of r, how will you go about it? From this equation, You have been given A, you have been given B, and you have been given R. How will you find the value of R here? You can apply Pythagoras theorem, whereby R will be equal to square root of A squared plus B squared. So what you will get here is what is called modulus, right?
Yes.
And it is denoted by this sign Z. That's what denotes modulus. So when you are asked to find the modulus, when you are given such an equation, you know how to go about it, right?
Yes.
Then you have this angle here, theta. How can you get the theta here? From this, using the formula of Sokatoa. We can use tan. Let's use tan. Tan inverse B over A. Right? That's right? Yeah. So this is what we call argument. And this is modulus. So when you are given an equation like Z, this is an equation, Z is equals to A plus JB, and you are asked to find the modulus of the equation, we know how to go about it, right? And also the argument. Let's use one example. For example, we have been given Z is equals to 2 plus J3. So if you are to draw an Aga diagram, how will you draw it? We'll start by, we'll have something like this. From this equation, which one will be our A from here to here? Our A will be 2. And our B from here to here will be 3. So when you are given such an equation and you are asked to find the modulus, how will you go about it? The modulus will be equal to, let's move together please, square root of 2 squared plus
3 squared.
3 squared, which will give us square root of 13. What if you are asked to find the argument, our theta now? It will be tan inverse of 3 over 2, which will be, using a calculator, you will be that 56.31 degrees. So from this, you know how to find the modulus, you know how to find the. So I'll give you some practice question here to do in pairs. So find the modulus and the argument. Okay, one group to do the first one, A. This group will handle the first equation, this example, then this group will handle the second. In pairs, please. You have like 1 or 2 minutes. find the modulars and the argument. Okay, 1 minute is over. So this group, to start us with question 1. Yes, Rita, can you handle question 1 for us?
So for assignment, you have to know the conductor, which is our A is -4, and this one is -4. So R is equals to square root of -4 square plus -4 square. This is the square root of 32.
Assist her with the square root of 32. You have calculators, use them.
5.66.
6. Now for the argument, theta is equals to tan inverse of -4 over -4. This is the same as tan inverse of 1, which is, so our angle is 0.5 degrees.
Is that your representation? Okay. The other.
Yeah, they are asking, is your representation here? Okay, because I've been given the negative and the negative. How will you represent
No,
it?
it's not in this question.
Yeah. Fine. Very fine.
Frida, ini inatoka kwa ndani.
Ate?
Utakuwa katika
Nitoka huku.
Yeah, this is okay. This should be an imaginary line. So it should be represented by dotted line, right? So these are negative, these are negative. We are looking for this angle, and the angle is 45. But it is in which quadrant? Third. So the angle that we need is this one. How are we going to find it? This is our theta now.
So it will be itakuwa negative minus 45. Itakuwa
No, it will be 1 minus 45. So our number is 1 minus 45, which is 135 degrees. That's our argument. Okay, let's proceed. We now have to introduce the polar form. So from this agar diagram, if we were to find the value of A using the Sokatoa method, we can say sine theta is given from this agar diagram. Sine theta is given by using Sokatoa method. Opposite over hypotenuse. In our case, our opposite is B. Our hypotenuse is R. We want to make B the subject of this equation. We'll have B equals to R sine theta. What about finding the cos theta? From this equation,
Adjacent over
will be adjacent over R. Making A the subject of the equation, we'll have A as
R
R
cos theta.
theta. From our standard complex equation, which is given by Z is equal to A plus JB. You remember this standard equation?
Yes.
From this, you can substitute the values of A and values of B. So we'll have something like Z is equals to
R cos theta
R cos theta plus
J
J. Remember we have J here. J
R sin theta.
R sine theta. You can factor out the common R, which will be Z is equal to R is equal to
Into cos
theta
theta
plus J
sin
sine theta. So this is what is referred to as polar form of complex numbers. If you are asked to find the polar form of complex number, this is what they are asking you to find. Let's have an example. So you have been given 2, Z is equal to 2 plus J, 3. How do you find the polar form of this one? You will first draw the Agar diagram to see where the equation lies in this equation. So you will have, from the equation you can tell that it lies on the positive side. So you'll have something like this, theta, then you have 2, 3, right? So from here you can find the modulus, which is R, is given by square root of 2 squared plus 3 squared. Then from there, you find our argument, which is given by tan inverse 3 over 2, which is,
Was it for
from here, you can substitute now the values that you will get from here, you substitute from our original equation of polar form. So we'll have Z is equal to R into cos theta plus J sine theta. So from here, our R is equal to, from here,
root 13?
from 13, right? Root 13 into cos. Our theta here will be
56.3.
56.3 plus j sine 56.3, and that is our final answer. This is polar form of a complex number. So I'll give you some more examples to do here. So I represent this. This is the standard form of a complex number represented in polar form. When you are done, I'll be marking as you exit the class. Individually. You do this individually. And I'll be marking as you exit the class. Represented in polar form. So I'll stand here. When you are done, just come. I assess your workings, then you go out. Okay, this is well done. Have a good day. This is well done. Okay. This is well done. Good day. I see you are struggling. So for you, it will come for okay, for those remaining, I think that question might take you forever. So I'll give you as your follow-up activity, and you will show me your workings when we meet next time. So today we have learned about the polar form. Using we have learned about the modulus and argument, and also how to convert polar form, complex number into polar form. So next time when we meet, I expect you to be conversant with this, and we'll continue from here. Any question from class?
No question.
No question. Okay. Have a good day.
You too.